We are Group 14, Indoor Localization System, sponsored by Ms. Susan McGrady from 8th Street Community and advised by Dr. Emil Jovanov.
Individuals with disabilities can find themselves fixating on tasks for longer than they should, and we've worked with 8th Street Community, a community for differently abled adults, in order to provide a solution that still provides autonomy.
We've been working on a system that uses UWB ESP32 room module sensors to track user location within a residence. These signals are sent to a Maria database with MQTT that is connected to a mobile app. When the user has been in one place for too long, then the user receives a notification to get moving.
Hi, I'm Oriala, and I pioneered the work on the sensors and their integration. Developing an Arduino, I created a framework for the anchors, sensors, and tag. I utilize ultra-wideband ESP32s for the anchors as they operate on a higher frequency, are less prone to noise, and are equipped with time of flight, which assisted us in our distance calculation. Next, the Adafruit NRF 52840 Express feathers were used as tags, utilizing received signal strength indicators, RSSI, and Bluetooth Low Energy, BLE, which is low power, cost-effective, and versatile. The sensor's capabilities are measured using a Python script that continually collects the sensor's location, RSSI, and the connected tag's proposed distance. This is loaded into a JSON that is configured in the database. Each sensor contains firmware and a script for trilateration, a method that conjugates the tag's data in relation to the three most nearby sensors and ascertains a relative position. This methodology led to the process of placing roughly 2 sensors per room at predetermined positions.
I'm Amelia Poulton, and I've worked on creating the database as well as integrating all parts of the project. I used a Raspberry Pi 5 where I uploaded the Home Assistant OS onto, and in Home Assistant we are using the MQTT broker and the Maria database server add-ons in order to connect the mobile app to the anchors for location data, as well as having a place to store all relevant information. The MQTT broker is used to send the distance data and the JSON for the 2D mapping integration to the mobile app.
Hi, I'm Min, and I worked on the hardware side of our indoor locator project, specifically the 3D printed enclosure. We designed the case using Fusion 360 and went through multiple prototypes to improve both functionality and practicality. Our first prototype was basic open case design. It was simple and helped us quickly check the fit of the chip, but it didn't include a lid. The second prototype includes a top cover with vent holes to release heat from the chip. This time the print came out correctly with the base properly opened. We also added a charging port hole to make it more functional. The third prototype will be our final version, and we plan to add bracelet slots so it can be worn on the wrist. This process helped me refine the case design to meet real-world usability and thermal needs.
I'm Emily Moody, and I worked on the mobile application. The mobile application has been developed using Flutter with both a user and administrator interface. It uses Firebase API to provide Google authentication. Administrators have the ability to create floor plans for the residences and indicate where sensors are installed in the residences. Users can update the time window for which they are being monitored, and administrators can update the default time monitoring windows. Activity logs and previous notifications are saved, and the users have the ability to annotate them to keep admins up to date on what they are doing. Reports are also created regarding user activity at the end of every day, week, and month to monitor trends in activity.
In conclusion, ILS aims to handle indoor location monitoring with precise resolution without the use of GPS signals.